Hi, everybody. Sorry I can't be there today, but I'm going to take a few minutes to sort of walk you through what I'm expecting out of the time that you're in class today. So I'm going to actually have you come up with a hypothesis about what your gel should look like, and then we can sort of get back together during block day and see what the gels actually did look like. There were a couple that seemed to work. I'll do a little number crunching on them over the next couple of days, and we'll see what the story is with them. But I want you to open this page up after you finish the video. It's on the assignment, and what you're going to be given is this page. And what I'm hoping that we can do is sort of hypothesize what your gel should look like for the for what we have done. So wouldn't it be nice if there was a place that we could go where you could see what it would look like when the enzymes that we have cut the DNA that we have, and then it's run on a gel that looks like what we have. So what you're being asked to do is, how convenient, there actually is a place where you can go. So you can go open up a browser. You're going to go to neb.com, which is New England Biolabs. And we're going to go to Tools and Resources. And then you're going to go to something called NEB Cutter, which is this thing. And it'll take you to this page, and if you really want to, you can load up a DNA sequence. You could type it in, a bunch of A's, G's, T's, and C's here. Or if you know we're dealing with a plasmid, you could specify the plasmid here. P-glow is a plasmid that we're going to be using a lot later on in the year. Or you can use lambda-phage DNA, which is what we are actually doing. So they've actually preloaded lambda-phage DNA into this tool, and we can hit submit. So now it knows it's going to look within the lambda-phage DNA, which is 48,502 bases long. And you can see a couple, these are just enzymes that New England Biolabs comes up with, and where they cut in this piece of DNA. So what we're going to do is, wouldn't it be nice if there was a way we can create a custom digest, which when we say digest, that's the process of the enzyme cutting the DNA. Wouldn't it be nice if there was a custom digest tool, and there is, so you can click on custom digest, and then you take it to a page that has all of New England Biolabs restriction enzymes that will cut on lambda DNA. And if you know the poster in the back of the room, this is pretty much the same thing. Again, it tells you where the cut site is. Some of these are a little easier to understand than others. It tells you how many cuts are going to be in the in the DNA, and it tells you which buffer it works best in. So, for example, I know that, let's pick AAT2. So you pick AAT2 and make sure nothing else is picked. So then you click digest, and it'll run through its algorithm and show you the sites that AAT2 will cut in the DNA. And if you want to see the gel, you can actually click on View Gel, and lo and behold, here's what the gel will look like. So you can maximize it, and 0.7% agarose is the DNA size that we use. The marker is a 1 kilobase ladder, so now you would see what this would look like next to our ladder. And what you could do next, what I'm really hoping you do, is you hit print screen, and then you open up a Google document and you paste it on the Google document. And then you can go back to NEB Cutter again. If I can figure this out, come on. NEB Cutter. And you could go to the other enzymes. Again, lambda DNA. You can go to the other enzymes that we actually had been working with. So custom digest. And then you can do BAMH1, which is down here, BSA1, which is a little further down, BSA1, and I'll put all the enzymes into the actual sheet for you. But that's basically paraphrasing what this all is. Okay. So something else I would love for you to do is, if you can sort of copy this down on a piece of paper. This is the molecular weight marker. Show us what the pieces of DNA, and you can be approximate, just draw down what bands would be about where. So, you're going to have a hard copy of the screenshots, which is exactly what your gel kind of should look like, including the marker. but then all of the enzymes on one gel, maybe even in the order that you put them in when you ran the gel, that would be awesome. You can write down, NDE1 is here, BAMH1 is here, BSA1, CLA1. You could, the band would be, or the bands would be here underneath the restriction enzyme, and hopefully we would see what it looks like. Finally, I'm going to ask you, on those pages, they actually tell you the number of fragments, and this is not exact. So some of the DNA fragments, we would have, 5 or 6 fragments that would fit here. I want to know how many fragments there are and what the length and base pairs should be, and that's information that will come from the website, right from the gel page actually. But I think I've got like a 10 cutter in there maybe that won't fit on here, so just use this extra space to add in, more for what you need. Okay, so I'm hoping that won't take terribly long, but I think it is a really interesting exercise in terms of what we're actually trying to get out of this. And again, the point of this is so that you know what your gel should look like. And again, on Tuesday, we can on block day, we can actually look at what your gel does look like. Okay, hope this helped. Have a wonderful day.